scenario modeling and how we'd approach that with this model. And then I hope to make it more a discussion at the end about the kinds of scenarios you're interested in. And we can chat about how exactly we would input them, but some background to give context to this. So before I start, are there any questions from previous sections that are hanging over? All right. So as I mentioned, today's session is on scenario modeling, and I'll do a bit of background, and then we'll have a chat, sort of a structured chat on what exactly one could do with this particular model. Yeah. So in terms of scenarios of change that we could look at in hydrological and water quality modeling, there are quite a few different types that you might want to think about. And I'll talk through a bit more on each one and how to do it. So the obvious one would be land cover change. And then there's also land and water management changes. So like agricultural management and practices, urban, suburban area management and practices. And then can also do water infrastructure and management changes. So we could change how different dams and transfers and wastewater treatment works are working, either their operations or even adding new ones or taking certain ones out or those kinds of things. And then climate change would be another one. And then there might be whole other things I'm not thinking of here. And so you could jump in on that as well. But these are just ones that I have some experience with and that are sort of obvious to do within the modeling framework. So in terms of land cover changes, could look at what trends you are thinking about preparing for in the future. Like urbanization is one, and that could look like either an expansion of urban and residential cover types, and that would have to include some information about how much are they expanding in which areas and what are the densities and cover types to assume that would happen at. It can be a change in density within the existing urban footprint as well. Or it can be, urbanizing new areas, changing the cover from whatever they were before. And then for cover changes, it could also be changing the area covered by certain crops or staying within the existing footprint, but switching what crop types are there. So, for example, I'm not 100% sure, but around this particular area, but I'm aware sort of closer to Durban and stuff, there are a lot of sugarcane plantations that have switched over to residential estates or things like that, or other residential developments. And I'm not sure to what degree that's happening here or other major changes that you're seeing in the landscape. And that would come with both a land cover change and obviously a management change if there was irrigation and fertilizer and those kinds of things that we had going in the model for that type. Other kinds of land cover changes to think about could be forestry plantation area or which trees are being planted in the forestry zones. That I'll come back to this, but some of these are less of a water quality impact, but they will impact water quantity, which does then actually impact quality as well. Another change that one could consider is looking at cover types close to streamlines to represent greening or changing the vegetation in buffer zones and riparian areas. Particularly, I was looking, there's some agriculture and forestry mapped right up to some streams. In some cases, there is a buffer, and in some cases, there doesn't seem to be one at the moment in some zones. And then one could look at alien invasive spread and either spread or reducing the coverage of them, clearing. And I did talk, when I talked about the inputs to the model, invasive alien trees aren't specifically represented in the model the way it's set up at the moment. But if that was a high priority for any reason, we could look at how to do that using some other land cover mapping that is out there. There's groups that have mapped this for KZN already, so that could be an added thing. Changes in like forestry and alien invasive trees, the water quantity impact of that is more direct, but there is a water quality impact, especially if alien trees are cleared. We'd expect higher winter flows in streams, and that would dilute concentrations of pollutants, for example. So those are things that could be represented in this model if they were of primary interest. Just to go over the land cover types that are in the model at the moment. They are, we reclassified the national land cover into 20 classes for SWAT to make the modeling feasible. And so that has 4 areas of residential density for and urban density for the cover. And I'll go back to that a bit because it's something to think about for the scenarios that you might want to think about. And then there are these different crop types that are specifically represented. So that's sugarcane, orchards, commercial irrigated, commercial dryland, and subsistence dryland. So any switching of these kinds of types, switching between these kinds of types, or switching what's on the different irrigated or unirrigated types are things that one could look at within the model. And there's just the map again. So to input that in the model, we created, I reclassified the national land cover map a bit and then made a linking code to have the SWAT model recognize what areas are what different cover types. And I'll come back to that when we think about how you could implement modeling a land cover change scenario. This is that consolidation of some of the national land cover types into larger classes for modeling with. And I wanted to show this again in terms of what's being represented in terms of residential covers and commercial and industrial covers. And we'll come into the properties of these that we might want to look at when modeling scenarios. So there's a low density residential cover type, and that was like what the national land cover map had as village scattered small holdings for a lot of the area. And then there's a medium to low density residential type, which is in between. Then there was residential medium density that I applied to the areas that the national land cover map classified as informal. And I'm not sure, looking at some of the aerial photography, they did get it right in some places, and in some places I'm not so sure it is exactly correct, but what we're working with for now. And then within these certain municipalities, uMngeni, Ubelebezi, Amdoni, excuse my Bezwe, pardon my pronunciation. These village and scattered and village dense cover classes, when I looked at the aerial photography, they fit in with the residential informal classes. Then there's there's residential high density, which was the following classes in those same municipalities that have bigger towns in them. And then there's commercial, and then I lumped industrial, roads, mines. There wasn't any area mapped as mines, I believe, but I linked the roads and industrial class as the highest impervious cover class in the modeling. So these are just highlighting what I said there. There was some classes in the national land cover map that I split up by municipality, as I mentioned before. But to summarize, we have this low density, medium to low density, medium density informal, and high density formal in practice. So for any of these land, like these urban and residential types, what we can change in the model is what some management of those areas and how that's represented in the model. So there are some options to represent septic systems in the model. And then sewage systems are represented as point sources from the wastewater treatment works. But we can add point sources to represent sewer leaks from particular areas given data. And I know Nintendo's, you've had some back and forth with Jason on information around the leaks, so we'll work on incorporating some of that. But one could have a scenario where those are added to or decreased. Other residential or urban area changes that could be represented as a scenario would be the percent imperviousness of a class, a land cover class, and then the connectedness of the impervious surface. And what that represents is like the storm drain network. And then urban and residential land covers and SWAT have a level of surface contamination that they assume builds up over time between rainfall events, and then it gets washed off in a rainfall event. So we can change the parameters of that to represent different levels of pollution coming off of urban and residential areas. And I'll come back to those parameters when I go into implementation and SWAT. So these are some kinds of things you could do scenarios with to change what's in the baseline model. Change what's you're looking at as things you might want to manage or look at scenarios for. For agriculture, one can change irrigation amounts. And so in terms of management, without actually changing any cover types, one could change the irrigation, tillage and harvesting timing, fertilizer or manure application and rates and timing. We're not doing pesticides in this particular model. You could do them. Riparian buffer areas, grazing practices, burning practices, and other conservation methods could be represented to some degree in the model. So one could have some scenarios looking at changes in these things if they were seen as a priority, or something you wanted to look at. And then in terms of water infrastructure and management, one could change the dams, their release rules, either their releases downstream as time series or rules that govern how much they release based on storage. Can also change the quantities of water withdrawn for use from the dams. Could add new dams into the system or raise walls of existing dams in the model. Could look at wastewater treatment works, could change the release rates and the concentrations that are assigned to different works in the model. You can add new ones, decommission certain, like take ones out that are in the model. Transfers, we could also change the amounts of water transferred or add a new transfer scheme. So the Moy uMngeni scheme, one could change the amounts going between. So, and then for climate change, one could model climate change scenarios. You'd have to think about how it takes, there are quite a lot of decisions involved with that, as with any scenario modeling. But just to show you some of the work that's being done at UCT and their climate system group, they've been doing comparisons of lots of different global climate models and downscaling them to the different water management areas. And this graph is total annual rainfall, and then changes in percent versus the 1981 to 2010 average. Just for one potential climate pathway, quite an extreme one. What I mean by a climate pathway, that's just an assumption of how much greenhouse gases we think are going to be admitted globally going forward based on what development looks like, and there are different scenarios for that, and then how the climate will respond to that. But what you get is a lot of different predictions from different models and different assumptions. So each one of those gray and blue lines are different predictions of how total annual rainfall will change going forward. And the blue lines are ones done through CSIR. That's why they're highlighted. They're more locally checked. And these are for the different water management areas. So some of you might have seen this before, I'm not sure. But what you can see for different areas is that, yeah, some areas that the range of change is big, but clusters around 0. Some areas are clearly doing decreases. But if one wanted to do climate change modeling, it would be a question of sort of how many different climate input scenarios one wanted to use to get like a upper and lower bound, and what time horizon would you be thinking about looking at, like 2050, or if you do something close in time to current, we wouldn't expect much change from that. That would be, I mean, things are changing, but versus the current level of variability, and how uncertain the climate models are, it wouldn't be worth looking at a short-term horizon. It'd be worth you might as well use the current level of variability. But if you wanted to look out to 2050 or something, then it might be worth using some of the climate change scenarios. So that's something to think about going forward, and there's different data sets available to use for that. But there would have to be some sort of local downscaling to adjust the predictions and apply it on top of the data that's already being put into the model. So that was an overview of types of, so land cover, land management, water management, climate change. When we're looking at scenarios to model, there's different approaches that people take, and one would need to think about what's relevant for your management questions, or what's interesting. Yeah, what's relevant to your management questions. There's the approach of like storylines for the future, or doing individual changes one at a time to see what those individual impacts are. And there's limitations to both. So what I mean is, like, storylines for the future can be a range of changes in land cover that you predict would happen going forward. So as we go forward, it's not like only sugarcane will change to residential development. Like, other changes will happen at the same time as that, realistically. And so if you have kind of a storyline of various changes happening at once, you could model those together. Or if you wanted to look at the impact of just that one thing on its own, you could do that. So in terms of a storyline, like business as usual is a common one, which is an estimation of how things will change on the future just based on the trends seen in the recent past. So like trends of urbanization or other transitions that have been happening in the last 5 years, or 10, assuming that keeps on happening over the next 10 to 15 years, and getting a different land cover distribution based on that. Then there's sort of alternative trajectories or interventions. Like you could have, there's some policy change that changes the way that land cover is going to change, versus what's been happening so far. Same with water management. My points are coming up in not the order I expected. Okay, so alternative future projections could be like different assumptions about the way things are going to change versus what's been happening so far. So like climate or socioeconomic changes, changes that are driven by legal changes you're expecting or would hope to try. So like legislating different buffer zones around rivers than have been, or other legislation around the limits of effluent from wastewater treatment works, or other kinds of policy changes you think could happen, and then how does that impact the scenario you're going to model? Could be targeted investment in new infrastructure, and looking at combinations of those things that you think are reasonable alternative potential futures versus business as usual. Or it could be modeling individual changes to look at their potential impacts with the understanding that realistically, like really in the future, a lot of things are going to change at the same time, depending on how far out you're thinking about or looking. But it could be changing specific agricultural practice, preventing sewer leaks, building a dam, all of these things just one at a time, with everything else about the catchment staying the way that it is currently, or in the baseline model case. It's not a realistic future case, but you can then look at the relative impact of individual things. But sometimes it is nice to look at multiple changes at once to see how they would work together. But it can be used with sort of an understanding that it's showing this in context of everything else staying the same. And then when you look at the outputs of modeling a scenario, we need to decide what the baseline case would be. So what are you comparing your scenario to? And generally that's either like a model of the present day or the recent land cover and management. So the model I've been setting up to date is using national land cover for 2022 and calibrating against the recent climate with more recent data. But I'm not looking at, change out into the future. The baseline could also be some business as usual prediction of how things might change, over the next 10, 15 years, if we have any ideas of that already. And I haven't looked for this area specifically, but I know some of the water management areas and others do like reconciliation strategies, and they make some assumptions about growth of towns and that kind of stuff when doing that. So that is something one could use in the model, or perhaps UW has those kinds of forward scenarios for like a business as usual prediction of the future. That could be like a baseline, and then you'd have your alternative trajectory as what you're comparing with when doing scenario modeling. The simplest route would be to just use the present day recent land cover and management model as the baseline for comparison. But it can be, if you're looking further out into the future, then consider a business as usual prediction for that future as your baseline. And then for modeling scenarios of impacts, one also has to think about what the climate input should be. It can be a longer term past set of climate data, or the more recent past set of climate data, which is what I've been using for the calibration run. One doesn't need to stick to the same climate data as we used in the calibration run. For calibrating a model, it makes sense to use that data, because then the land cover being used and the observed stream, so that we can compare to the observed stream flow data. But if you're doing like an impact study and you want to try and capture bigger and smaller events, or like drier periods and wetter periods that may have happened outside of that 2020 to 2025 period, then you might want to model the scenario with a longer set of climate data. So going back further, the HydroNet data that I have goes back only to 2019, but there's other data sources that you could fill in. and to make a longer data set, which is what we did in the previous round. And for scenario modeling, it's less key that we would use the calibrated model to start with, but then after that, we're not needing it to fit the observed stream flow anymore. Now it's like an experiment to check what we think the impacts would be relative to the baseline, so relative either to the current land cover and management or relevant to the business as usual land cover and management in the future. So then we can use different climate inputs. And then if one wanted to go further out into the future, it could look at running, using some future climates. And I'd only recommend doing that if you were thinking of looking out to like 2030 or, 2050 or beyond. Otherwise, the uncertainty versus the amount of change predicted might not be worth the effort. But one could look at a longer term run for a scenario modeling than this 20 to 25. There we go. Okay. So yeah, so we need to pick a baseline, and then one would run the model for the scenario and run the model for the baseline and compare them. And last time we talked a little bit about looking at the outputs of the model and what kinds of outputs and statistics are interesting for you. So there is there's just the daily hydrograph of stream flow every day and then water quality outputs for every day. But you probably want to summarize that in different ways. So it can be how often, how frequently, water quality concentrations are above X amount, or what are annual or seasonal or monthly values or daily extremes, minimums and maximums, or the 95th percentiles of the extremes at different levels. There's ways of looking at things of frequencies of extremes over time, how often is the flow above this level? How often is the concentration of ammonia or nitrates, etc., above a certain level? So how does that change between the baseline model and the scenario model? So this is just an example figure from another study, but it's looking at changing climate and land use, for example. Sorry, it's not color, so it's a bit trickier to pick everything out. Oops, sorry. But there's a baseline model that's a black line, and then there's a climate change that's also another dark line. I think the baseline one is the thicker one, and then there's like increased urban cover, increased forest cover, and I think some best guess of a future combination. Not sure what I can't remember what the best guess one is, but you can see what they've plotted is the frequency distribution of different flows to look at the distribution of high versus low flows under these different changes. And then also, the flood return period of different flood peaks. So how big is the 20-year flood, the 1-year flood, the 2-year flood, the 5-year flood under these different cases. So these are different kinds of things you could do with the model outputs after we'd run them for both a baseline case and different scenario cases to see the changes. So it'd be a question of how UW wants to analyze the outputs, what kinds of outputs are interesting or would help make different management decisions. And then another thing to note is that in the calibration stage of the model, so the last time we met, we talked more about calibration, kind of what and the error and performance statistics and what they point to. And so those performance statistics are the baseline model versus the observed data, and they can be used to estimate uncertainty bounds around the scenario outputs. And you can use those bounds we should be using those bounds to relook at how much change we're predicting So in the bottom right of this figure, for example, if you say those clusters of lines are, the bottom cluster of lines is the baseline and the top cluster of lines is the scenario with some uncertainty bounds around it. What I've shown is like that green arrow, the green arrows show a smaller degree of change between the bottom of the uncertainty band of the scenario and the top of the uncertainty band of the baseline. And then the orange would show like a bigger degree of change. You could do a degree of change between the middle and the middle, or between the top, the top and the bottom. So the amount of change we would talk about, you could be conservative about it given the uncertainty in the modeling. If that, oops, sorry, it's advancing by itself. If that makes sense. And so if you're looking at sort of extremes that you want to plan for floods, you might look at the biggest change predicted to be conservative about it. Or if you're looking at like gains in water from alien vegetation removal and you want to be conservative, you might look at the smallest degree of change, considering the uncertainty bounds. Also giving what the middle, the change between the middle and the middle is, but understanding that the model is uncertain and so is the scenario modeling is probably even more uncertain. We generally want to be quite conservative about how much change we think is going to happen. So these are just diagrams from elsewhere too that illustrate that fairly nicely, I thought. In a climate, the figures are from a climate change setting, but it could equally be applied to land cover management settings or land cover change modeling. Please do just stop me if I'm saying something you want to ask a question about, or we can also come back to things, but if anything's confusing, please just unmute and ask, because I don't always see anything in the chat. Does anybody have any questions at this point? I'm going to go on to talk about how one would model, how one would actually implement some of these different scenario modeling options in SWAT Plus, given our model. And I'll flip back and forth between the SWAT Plus screen to show you where one would make the changes, and back and forth between the presentation and SWAT Plus. So to implement a land cover change scenario, I've put this line. I'm figuring you might come back to these slides at different stages in the future. So I've repeated this line every time that it's best practice to make a copy of the baseline model and then give it a new name and implement the changes there. SWAT does have an option to, like, when you run a model, to save as a scenario within the modeling project. But when I look online at user forums and etc., they suggest actually making a whole new copy of the modeling project, and that's what I've done in previous, just because it keeps everything cleaner and you can't end up with a mix-up where you save over your baseline model by accident, which can easily happen with some of the other routes for doing this. So I'd highly suggest, instead of trying to use the internal scenarios within a project, that you would make a whole new copy of the project and the model with a new name, and save it and implement the changes there. It keeps your baseline model more safe. So what you can do then is, let's say you want to model a single simple land cover type change, like changing from sugarcane, like all the sugar, oops, sorry, I advanced, like changing all the sugarcane area to low density residential everywhere in the whole model. You'd have a different approach to doing it than if you wanted to do that in just a specific zone or location, which you could also do. But if you want to do a simple change of like all of land cover A becomes land cover B everywhere in your whole model, you can actually you don't need to do a lot of work to implement that. You could just change the vegetation that's assigned to the map land cover type in what's called the land use management table in SWAT Plus editor. So I'm going to go through these approaches and then I'll show them to you in SWAT Plus. But I'll just go through this slide first and then I'll jump over. Another approach can be if you want to change a single cover type in specific subcatchments or locations to be some other land cover type. And in that case, you wouldn't change the whole land use management table. We would change specific HRUs, what land cover is assigned to them. And you can do that for groups of subcatchments or all the HRUs that are a certain land cover type within certain subcatchments. So I'll show you that as well. And then if you want to model a more complicated pattern of change, so we're like changing, it's an urban expansion, and that urban expansion is happening over a bunch of different cover types around the edges of Maritzburg or around the edges of somewhere else. There's going to be different land cover types changing into different other land cover types in more of a complicated pattern. So then we'd actually make a whole new land cover map in GIS using the same cover classes. And then we would actually have to go back to the HRU delineation step in QGIS that we did. So that would, we wouldn't have to redelineate things like the streams and the subcatchments, etc., but we would have to go back to the HRU delineation step and import our new land cover map. And it could come with a change in soils as well if you wanted to, but the way I've set up the soils, it wouldn't necessarily, but it would just be a new land cover map. And then you would then go back to SWAT editor in your new setup. And if we've made like any special cover changes and management changes, they would have been lost. And so you'd have to redo those changes in your new model. So I'll show you these approaches briefly in SWAT Plus. So let me exit my presentation for a sec and switch over to SWAT Plus. Okay. So the first one I mentioned was in the land use management table. So this is the SWAT Plus editor again. And this is where, let's see if I go to the home, like this is our setup of our whole project. Shows how many HRUs and the different land cover, distribution of land cover types. So we've got like rangeland, sugarcane, pine, etc. And this was all derived from our the QGIS stage. And then if we wanted to change, let's say we just want to change all the sugarcane to be developed cover or like low density development. Oops, let me not do it there. We would go to our edit SWAT Plus inputs and we go to land use management. And there's a table that links areas that are mapped. So this is let's find. So sugarcane is SUGC. This is land use management, LUM table. And if I click on it, I can edit it. And it says that the plant community, so this is the land use management table for everywhere that's mapped as SUGC in our land cover map. I can change what vegetation is there. So I could change it to be a different vegetation type here. And then let's say, I don't want to actually change it in this model because this is my, I should have made a copy. But you would pull down and change the plant community that's there. Or if we wanted to urbanize it, we would change what urban cover is there. And then for the urban cover types, they're paired with the vegetation that's in between the impervious cover. So I've assumed that to be Bermuda grass as just a grass type. So you would change it to, if we wanted to change it to residential, you would change this plant community to Bermuda grass, and then we'd change urban cover to like medium density or low density development. And that would change for all the sugarcane area in the whole model would now, I haven't changed the land cover map, but I've changed what cover is being associated with that area now. And I would save that in my new version of my model, and that would apply that change everywhere that sugarcane would now be residential. And then I would save it and I could run. So that would be a very quick one to do. So that's just changing all of a certain land cover type to a different land cover type everywhere in the model. But you'd have to remember, I haven't changed the input map. So I'm just changing things in the background. So you'd have to keep track of what you've done because it might not be obvious. But that's the quickest, easiest way to change one type to one other type as a scenario. Another thing, and then another way you could approach it, like let's say we want to change, I'll keep with that example, but let's say we want to change sugarcane to residential, just in a certain subcatchment. The place to do that is actually quite different, but it does link to the land use management table. So there, you would go into these connections, this connections dropdown, and you'd go to HRUs. And you would need to know where you'd have to probably go to your QGIS and find one HRU that you know you want to change to start off with. Let me find a sugarcane one, for example. I guess you could find any sugarcane one. So you navigate through these pages at the bottom. So there's thousands of these. I'm just trying to find a, oh, you can actually sort. I think you can sort by cover as well. Let's see if I sort. Yeah. So if I go land use. Yeah, all right. Find. Oh, it's sorted within the page. That's interesting. Okay. Didn't sort it all. Find. There's many pages. Oh, actually, I can use the search function, I think. Can I? No, all right. What I could, I was hoping I could just sort by land use. Let me just go to the end. Well, for the sake of time, it would be easier if I'd gone to my map and found a particular HRU. Apologies for not doing that, but you find an HRU number that's sugarcane that you know you want to change. But let's pretend we're changing pine to something else, for example. So I would pick this HRU that's pine, and we'll go to its table. So this tells you that HRU 48 has pine. If I want to change many HRUs to, let's say I was changing it to sugarcane or something, for example, or grass or urban, I could change it by, I can change multiple at a time, many HRUs at a time, by going to this button down here in the bottom right-hand corner. It says edit multiple rows. And then it gives me up here, it gives me this windows at the top saying some sub-basin 1, 2. So you'd have to know back to your GIS, which subcatchments do you want to change it for? So if I wanted to do it for 2, 3, and 4, for example, I could pick the different ones I wanted to change it. And then I could pick, it's going to change this pine one as well, which is why it's nice to start with one HRU that you know you already want to change. But let's say I want to check all the pine. Now we're doing a different example. So if I want to do all the pine in these subbasins, subcatchments, and then I could just do all the pine. So then it doesn't matter what soil it's on. Or I could do the pine that's only in the lowlands, for example. So my lowlands, the soils also match the lowlands, so lower numbers were the lower level soils. If I just do the ones and the twos. And then that's going to pick out the HRUs that meet my criteria here. So subbasins 1 through 4, pine classes, picked out the lowland soil classes only. And then if there are HRUs I wanted to exclude, I could uncheck them, but this list is just going to be the ones that meet these other criteria. Then I would go and say, I'm going to change what, and then, yeah, and then you could say, I want to apply this change to it, and then I would change this to whatever else I wanted it to be. So if I'm saying this pine is going to become agriculture or like range grassland or something, I could change it there. So that would change that vegetation in these specific areas. And then I would save my bulk changes, save my project, and I could rerun the model, and that would be a scenario that included those specific changes. But I'm not going to do that. I'm going to go back without saving my changes. But that's a demonstration of how you could change one class to another for some specific areas within your model as a scenario. So you can either change everything, you can change one class to another class within a certain area. And then there is the route of when you have quite complicated changes, you wouldn't want to do it that way. It would be too many selecting. You would need to make a whole fresh new map of land cover and import that and make a new version of the model. So I've left some notes here about how to do that. So like SWAT editor, change the vegetation in the land use management table. And then for like doing it within a specific area, you could change the land use management properties assigned to HRUs by going to connections, HRUs, edit multiple rows, the way I just showed. So those are two approaches to do simple one cover type change. And then the mapping route would be a GIS work operation. And then the steps that we took in some of the other class sessions in terms of bringing in the new map and delineating HRUs. Are there any, before I go on to some of the land management changes, are there any particular questions about this at this point? I can also come back before I go on. I'll go on for now. Again, just unmute and stop me if you want to ask things. So then we talked about, in addition to, or as well as changing just land cover, we can change various aspects of land management. And so for every land cover type in our model, there's different elements of management that is represented in the model. And I will show you this table, but it's I'll come back to it when I get to another specific example that I wanted to go through. But there is this land management table for every land cover type, and it includes what vegetation is there, this plant community column. And then there's management scheduling, like crop rotate, like when crops are planted and when they're harvested. And then roughness for stream flow, surface flow of water across them. Then there are other conservation practices that can get represented in this link to the roughness. And then there's the urban cover parameters that we'll go into just now, and a strategy for how to measure the urban wash-off. And there's different options there as well. And then this is the roughness, apologies. And then we can add septic systems to a land cover as well, if you wanted to represent that So there's various things, and then there are management schedules and operation schedules that go alongside these in terms of when when crops are planted, when they're harvested, and what fertilizers and pesticides are applied, and when, and irrigation timing as well. So one thing I mentioned previously when we're thinking about what, general types of scenarios one might want to model, urban densification without actually changing the footprint of the urban area. If we want to change the footprint of the urban area or the residential area, then it would be those land cover changes that I mentioned that we just went through as well. But let's say we're keeping to the same footprint of the residential and urban areas, but just changing things like how impervious, the percentage of impervious cover that's on them. Other things you can change are the connectedness of the impervious cover, which represents stormwater management, essentially. It's how much of the water that runs off the impervious cover is either routed to a vegetated area where it can infiltrate into soils, or routed straight to the river channel. So there's no chance for any like evapotranspiration to happen or any filtering of the water quality by the soils and the vegetation. So that can be set for specific urban land cover types. I say urban, SWAT uses shorthand urban for all, even like low density residential types that we might necessarily call urban. We might call them suburban, etc. But in the model, it's all classed as sort of urban, as urban topology. So there's a database called the urban database, but there's low density residential in there. So to change some of these properties for a specific cover type as a scenario, could be something about change. It could be representing, you want to model what if we change something about the stormwater management that could be represented by this connectedness of a pervious cover. Or if you think certain zones are densifying, you don't need to do a whole new land cover map, etc. You could actually just change the percent impervious cover for certain urban types throughout the model. So I'll flip to the urban table in SWAT Plus in a moment. If you wanted to do it for specific sub areas, rather than for the whole, like all the low density residential in the whole model, if you wanted to do it for specific subcatchments, it would be a similar process to what I just showed you, but I'll show you it again in the urban database context. Because it would likely require making a new urban cover type. So let me show you that now, just as an example of how to change management parameters in the model. Oops. I'll go to SWAT Plus. Oops. So if you wanted to just change, I'll show you the urban table. Oh, sorry, it's not there. It's in databases. So each urban cover type, like let's look at low density, for example. So that's URLD. This is residential low density. I don't know why. I didn't put all these decimal places in, so somehow they've come in on their own. It's interesting. And they're very close to these values. So with the value matches, this column here that says dataset value, that's the default in SWAT. And it'll be blue. It'll turn blue if your value is the same as the default value. So that's kind of helpful to see. Why? So it explains each parameter. So the fraction of the HRU area that's impermeable cover, so impervious, is 12. It's 12%, 0.12 for the low density residential development class. The fraction that's directly connected is 0.1. So the 12% total, but 10% of the total area is directly connected. And then the curb length density has to do with drainage as well. And then the wash-off coefficient for the removal of constituents from, so that's a fraction of per millimeter of rainfall, what fraction is going to wash off of what has accumulated per length. So it's assuming that wash off in urban areas happens along like a storm drain line along the curb length of a street. So the thing is, the layout of our residential areas is not always exactly like that, but these parameters can be changed to increase how much of what we think is building up on the land surface in between rainfall events washes off. And so there's a time for buildup, and then there's what is building up, the concentration of nitrogen. So essentially it's considering it like urban atmospheric deposition, like dust and car fume deposition. But we could increase it to represent other things. So these values end up being fairly low based on atmospheric deposition assumptions in urban areas, for a lot from car exhaust, but you can say we could up these values to represent things like urban fertilizer use, or I think sanitation might be better represented with either septic systems or point sources, because this is just nitrogen and phosphorus and doesn't include ammonia. Well, it's nitrates. Okay, total nitrates and phosphorus. But once we add, the model's not doing bacteria, but they're busy adding it. And once we add bacteria, we would want to include that, and that's not, that would have to be included as a point source. But one could increase what's washing off different urban covers using these values. I've used the defaults so far. But a big one, like an easy one to change to look at if you had information about how it might change, is the impervious cover percentages. So if we go back to the other urban cover types, so you could change these values for a cover type. That would change it everywhere in the model. So it has low density as 12% impervious, medium to low density. Let me sort it by fraction. Yeah. So industrial, commercial, industrial 87% and 79% is directly connected to a stormwater drain. Commercial 67 and 62, high density residential 6, but much less connected. So assuming there's some level of lawns or gardens or green space in between. So it's only 44 is directly connected. Institutional, which we didn't have in our model, that then there's medium density 38 and 3, medium to low 20% and 17% connected, and low is 12% and 10%. So we can adjust these values also as part of calibration, but once it's calibrated, then we could also adjust them to represent scenarios around densification and stormwater management. We can also adjust some of these concentrations of like how much nitrogen and phosphorus is assumed to sort of build up on the urban surfaces or the residential surfaces, and how it washes off, to represent different scenarios there for the urban and residential areas. And then if you wanted to do, if you don't want to change the parameters for all of like the high density residential areas in the whole model. So one thing you could do, for example, you could say all the low density residential areas become medium density residential areas. So that we would approach it like a land cover change scenario. in using the instructions for the land cover change, because we just changed low density to high or medium density everywhere in the model. If you wanted to say that all the low density or all the medium density change their management a little bit, you could change these parameters. If you only wanted to do something for a specific area, one thing you can do is also create a whole new urban class that has a different set of values here. So you could do create record on this urban databases table. And if I do that, I can make a new name for my new urban type. It's usually a 4-letter abbreviation and then a longer description. And then I can pick the values for fraction, pervious, etc. If I don't want to change any of these ones, I want to leave them as they are as options, or they exist in my model the way that they are. I can add a new one that I want to apply to some areas. And then I can go back to, apologies, my HRUs tab, and I can then change it, change specific HRUs, like this one's urban medium low density, maybe, and I can do this edit multiple rows again, and I could say like in subbasin 11 and 12 for all the urban medium to low densities, all soil types. I want to change it to whatever my new urban cover type that I made is. I would change it there, and then I would apply that, and then all of these areas that were urban medium to low density would have my new urban cover type with its different parameters on it to represent a management change in those particular areas. So I'm not going to do that. I'm going to go back without changing. So that would be an approach for changing urban things like urban densities and stormwater management. Oh, the other one I wanted to show you was that one could also change add septic system, which I'm not sure if you have information about septic systems. It could be used to represent things like areas of pit latrines and stuff. I'm not sure how much that is something you have data about or want to get into, but it would be possible through here. So there's septic options. So if I go to like low density, and then there's this this shows, what's the urban land use and the various like runoff, wash off, Manning's N, and then there's a septic tank option here. And I could click on it, and you can have failing and standard are the options that are available to add septic systems. And you can also add other options for how septic systems are represented in this database. So when I go here, it has failing and standard. If I go to databases and septic systems, there are these, let's see. I expected it to be failing and standard, but there are, okay, so there are links we can make between this table and the other one, but what you can add about a septic system, you can have like flow rates, biological oxygen demand, suspended solids, phosphorus, nitrate, effluent. Okay, these are what's going into the tank, but then you can say this kind of tank, is it failing or is it standard with these concentrations? So this one doesn't have. Let's see. Go. Okay. I'll come back to the septic because I thought it was there. The operations. But if we want to get into septic systems, I will see how that link works between the failing and standard and those different types in the databases. I haven't used that yet, but it was an idea of a way of adding other sanitation options that would work differently than a point source. But a point source may be a cleaner way of doing it. It depends on the data that we have. Nintendo, just while we're here, well, I was talking about septic systems though. Does UW have data on septic systems or areas of pit latrines that you think is worth trying to represent in the model?
Just to answer you, we don't have any data with regards to the septic systems, but we know certain catchments that do have may have some septic systems and also pit latrines. One of those catchments is there are various informal settlements in other maybe I can say medium density urban areas that's associated with some pit latrines and septic systems. But in terms of I also wanted to ask when we were discussing that I think you were touching on there was something on flow rates associated with septic systems, and I wasn't sure if when you're talking about data, you're actually talking about those parameters. I mean those volumes that we need to understand as well.
Yeah, I think like those, so I think a starting point would just be data on if there are areas with a lot of septic systems in a certain area, then it might be worth representing that in the model. In terms of the flow rates, it's not likely that you'll have that, but there might be studies that estimate it for a region or for South Africa that we could use. I'm guessing it's not likely to have that specific data, but you could change, like it's is for a, it's not like individual septic systems, it's like this whole block of a land cover type has some septic systems, and roughly how much of the wastewater it's producing, or the wastewater it's producing is going into septic systems for this whole block of a land cover rather than one septic system at a time. So it would be sort of the proportion of the population, or the proportion of, we would have to estimate some sort of amount of flow into septic systems within that area. So it would take some estimations. So I'd treat it more as a scenario than saying you have much, but you could look at increasing it or decreasing it. It's one approach for representing those things if we think that it's a large impact on the water quality in an area what you want to look at. So at this point, I haven't played with it because it is another level of data than what we have readily available. But if you find that you have like quite a lot of information about just like this area has, more than half of, it has a lot of septic systems or a lot of pit latrines, or most of the population in this specific area is using that kind of sanitation, then we could try and make some assumptions about it to include it and see what that does versus not including it. Yeah, there's a lot of things you can include in this model, but it's only if you have the data on them. But if you think that they're very important or they're having a big impact for some reason, then we try and make some starting assumptions as we gather more data on it. Hi, Ntando.
Yes, I wanted to comment that for most of our urban catchments, I think that's actually affecting us in terms of water quality. They are connected to the sewer network mostly, and you find out that they surcharging manholes and sometimes illegal connections that are actually are also discharging to some of the water resources. But in terms of septic systems, I think mostly for rural catchments, like your Hazelmere, we've got some in the South Coast as well. So for those catchments, we might have mostly in terms of the sewer systems, they use septic tanks and pit latrines. So for those rural catchments, we can maybe try to include them in terms of septic systems. But for our urban catchments, mostly they are all connected to the SWAT network. And I also wanted to ask, in terms of those default values that are within that we're trying to change, are those parts of the baseline model that you ran for this uMngeni catchment, or those values are defaults in terms of their estimations based on literature and other various sources?
These ones are the ones I just showed a default, but I did adjust. Well, they started with a default, but I adjusted them. See, is this version? Let me find that. Bring that down. Urban adjustment line. I did have to increase some of the imperviousness, which is not in the one I just pulled up on the table. So let me. Calibration charts. I will pull that out. I did have to increase some of the impervious surfaces in the medium and low density. Are you asking because you have specific information on the imperviousness?
Not really. I was just asking just to understand the model framework. When one will be trying to adjust these values, trying to figure out if the model come with the specific values or that one can change or leave them as they are.
So yeah, it does come with specific values. It does come with default values. And then you can change them from there. So I tend to start with the default values, but if I have specific reason to change them, I will change them. Like if there's more local data on it. What I was finding, I've changed the density a bit, like when I find if I find like all the urban catchments, for example, like let's say you find all the highly urbanized subcatchments, the model is not producing enough, the flow peaks are too low, but only for the urbanized catchments particularly. Like the most urbanized catchments, the flow peaks are always too low. Then you know it's probably something to do with the way the urban or the residential cover is being represented in the model that's causing that. If that problem is not happening anywhere else besides the most urbanized ones. And if the peaks are too low, then you probably need to increase the impervious cover or the connectedness of it. And then what I would do there is also look at, is that area actually higher density than the rest of the area that's mapped? The thing is, the national land cover dataset is quite coarse, so it's mapped large areas with a bit of a variety of density to be all the same. And then knowing what the density of impervious cover to apply to that area is a bit tricky, but there is there's been a study trying to make a national level database for SWAT, but they were also doing it at the national scale. So again, it's quite rough. So then you might find that actually this area is even though it's mapped the same in the national land cover data set as somewhere else, the density is actually higher in this place than in that other place. So there are some areas where I did increase the impervious percentages. And it made the peaks of flow quite a lot better in those zones. I think it was around like the Slangspreid. It was around Msunduzi that I had to do that. But now I've changed the classifications, so it might not be necessary again this time. Does that answer what you were?
Yes.
So the other one I wanted to go to, I'll just briefly touch on how to do agricultural management and infrastructure. But I'm just looking at the time. I do want to spend more time on you guys coming up with ideas of what kind of scenarios you'd want to do and what the outputs you'd want to look at are. So for agriculture, I'll keep this quite brief. So it's similar to the urban what I've said for some of the other classes. So if you want to change management for cover types without altering, like we're just changing the management of sugarcane, you can change it for all sugarcane in the model using that land use management table, or you can change it. Then the best thing would probably, if you want to change like practices on sugarcane in just one sub area, the best thing would be to add a new land cover type like sugarcane 2, and then assign those areas to sugarcane 2 with the new management properties attached to sugarcane 2, and then assign like that specific area to sugarcane 2, for example. Like they stop using the fertilizer they were using before. They use a different fertilizer than the rest. So the way the baseline model is now is like all sugarcane anywhere in the model is treated the same. And all crop area, like the dryland crops are treated the same, and all, because I don't have a bit more specific information, but it could be added, or it could be added to improve the model, or it could be added as a scenario that you want to test. Like, what would it look like if these areas did that? Either because I think it's like something we could ask them to do or legislate them to do, or it's something that some people are trying as a new agricultural practice or something like that. So you could change everything everywhere. You could change in specific areas. So that would look pretty similar to what I was showing you with the urban. Oopsies, sorry. In this land management, though, like for an agricultural type, there is a management schedule that has a rotation that you can set. So what's planted when. And the management schedule also has like when the fertilizers are planted. Sorry, this is a demo one. So it has plant and harvest for a continuous winter crop. But I have ones that model is running in the background, so I don't want to mess it up. But you can change various schedules in the schedule building. You can add operations like you have planting, harvesting, tilling, irrigation, fertilizing, and pesticide. And then you set rules about when it's happening, what pesticide or fertilizer it is. And then there's a fertilizers database that has the concentration of nitrogen, phosphorus, ammonia, nitrates, ammonia, phosphorus, etc. in the fertilizer type. And then you can set the timing at which that would happen. and what would, or it can be with irrigation, that it can trigger it by how dry the soil gets as well. So you set up a schedule with, when either days of the year or heat units. So if you think it varies by how warm it's been up to that point, which is another strategy, or it's when in the year it happens. And so this one is for planting. So it says what vegetation are you planting? So you can cycle between like maize and wheat and stuff. You can have maize planted on this date, and then wheat planted on this date for the plant operation, and then you add a harvesting and killing. So you can set that up for your different agricultural types, and then you can change it if you want to see what a scenario of change would look like. And so you can change it for an entire mapped land cover type, or you can make a new land cover type with your different management and then assign a sub area to that different one. So you do create record here. And you would make a new land cover type and you would link it to what vegetation is there, what's the management schedule, and then you would have to assign some HRUs to this new land cover type that you've made that's a different agricultural management. So then you would go to your HRUs the way we were doing before. We said edit many, and you'd say which subcatchments, and then maybe the sugarcane, and you're assigning it to sugarcane 2. Like these subcatchments, these areas are managing their sugarcane differently, so I'm going to assign it to my new group. Using a similar approach to what I showed with like a targeted land cover change scenario. So that's the way to change, that's an approach to change agricultural management. Either for all the areas of a crop type or specific areas. So it's a similar process. Oh, sorry, the font is very small on this one, but this one's then other kind of scenarios one could do, which is changing water infrastructure and management. You can change the properties of the reservoirs, could make them bigger to represent increase, like raising of walls. You can change their release amounts or rules. And then if you want to add new dams, you actually have to go back quite a few steps. You have to go back to QGIS and add them at that step. So that's a lot more, it's a lot more work to do, but it's possible. Then for wastewater treatment works, changing their release rates and the concentrations of what's released is quite easy to do. I'll show you that. And then adding new ones is also is fairly easy to do if the network already has points along it at the place where you want to add one. If you want to add one that's like in the middle of a stream where we don't have a breakpoint, and it's important to you to add it specifically there, and it's not you don't want to assume that it's further up or down where there is already a breakpoint. Then we'd have to go back to the QGIS and redelineate the stream points with like a breakpoint where that new wastewater treatment works, and the same would apply for a transfer to add that. But I just want to show you the point sources additions quickly so you have an idea of that and then how you would change it for a scenario. So the point sources are under this connections tab, and then there are points. So in our GIS, all these points are points along the stream network, and you'd go to your GIS and see where the point is. Like my point source. Oh, it's in a different project. Point source reservoir. These are the reservoir points. But if we have I have a table of which point sources are associated with which wastewater treatment works. And then I have the outflows for them. So let me open one that has a wastewater treatment works on it. Resources. So let's do 234 is one of them. So if I go to 234 has a wastewater treatment works on it. So what I have here, this is a point source where there's a wastewater treatment works for Mpumulo Hospital. And then there's a daily time series of flow, sediment, organic nitrogen, phosphorus, nitrates, oh, sorry, sediment, phosphorus, soluble phosphorus, chlorophyll, ammonia. So I talked about the inputs of this previously, but you could then, this has a daily time series for the time period I made from the previous attempt of the model. But then if you wanted to change it, there is the option to change it. You could either change the daily time series, or you could actually, if you don't have so much information about the change you want to make, you could change it to, you can have like a constant rate per day, and then you can change that up and down. You can have monthly or yearly rates rather than a daily time series, depending on what information you have. So we can add things like that, or you could, you could keep the you could make a new daily time series if you had enough information to do that in a certain way, like increasing everything by a certain percent and then re-importing these values. And this can be done in Excel. So I have these files in Excel and also as comma separated values, and I could just make a new file and re-import it. So with these point source files, you would do, oh, that would be for editing multiple of them, but you can re-import your records. So import, export. So you'd have your files with your time series, and you could import them for your point sources. So you can see the ones, there are lots of, there's a point on every break in the stream network, and then the ones where it says daily at the moment. So the other ones just have constant 0. So there's no point source inputting there, but it's like an empty placeholder that you could add a new point source anywhere in the model that you wanted to. But the ones where it says daily are the ones where I've input the data for wastewater treatment works that I had from the GIS and the databases that were shared. So 250 is abattoir. So there's a table saying which point is linked to which point source. But a scenario one could do is changing these in certain ways or adding new ones to different degrees. And that's also the way that you do the transfer, interbasin transfer, and you could change the amounts of that. So that was done using the observed data. But that would also be the place one could add point sources to represent sewer leaks, if we have time series of amounts that can input. So I know some various information has been compiled, so we can put those in as estimated point source inputs. So that's what I prepared to present in terms of types of scenarios and how to implement it in SWAT from just like a technical, how do you input the changes in case somebody else is doing it later on. So you have that information. And then I also have how to the videos of how to implement it in SWAT. But I thought what would be helpful would be to get some more ideas from you in terms of what kind of scenarios you would be thinking you want to do with this model. And I can answer questions about how you might do that. Like what kinds of things would be relevant for why you wanted the model in the first place.
So I think for us, you've already covered some of the scenarios that we can consider. But I think one of the major issues that we are currently facing is the issue of failing sewer infrastructure, your wastewater works, pump stations, and also your surcharging sewer manholes. So I think for me, if we can prioritize that scenario in terms of looking at the facts that even our catchments, we are having issues of algal blooms now due to failing sewer infrastructure in our catchments. So in terms of priority, I would think that would be given high priority in terms of the scenarios that we can look at. I think you've already touched on the issue of land use change and urbanization scenario. It's one that we can also look at. Yeah, I think we can also look at that scenario because we do have some areas that are currently, your peri-urban areas that are currently getting urbanized in terms of looking at population growth and other issues. And I also wanted to find out from you that in terms of scenarios, are we looking at negative feedback scenarios only? Because I know that we are, as a department, we are also doing some ecological infrastructure rehabilitation work in some of these areas. Can we also look at those rehabilitation scenarios, their impacts on water quality improvement, if there's any? We are doing wetland rehabilitation in some of these catchments. If there's an opportunity to look at those positive feedbacks from those rehabilitation scenarios. We're also doing alien plant clearing, but at this point, that is focused on your aquatic weights within the infested dams. But there are other teams that are looking at terrestrial alien plants. So if you can also look at we can also look at ecological infrastructure and some of the positive feedbacks that we can draw. We can maybe motivate with this modeling work. I can think of those for now.
Nice. So that's a good one. So the wetland rehabilitation one is an interesting one. It could be a nice one to do. Is it being like when you say wetland rehabilitation, was the wetland what state was the wetland in were the wetlands in before? Like had they been converted to something else entirely, or what does that look like so far?
My colleagues will help me here, but one of the challenges is that most of our wetlands are already degraded. So we we actually, there's not any wetland that I know of that we find it actually in a good state. Most of them are very degraded, and you'll find out that there are drains and everything. They've drains and everything within those wetlands. So yes, most of them are not in a good state, but we are also we've already implemented some artificial wetlands as well. So if you can also look at the benefits of those, I think we've got one. It's Darville Wastewater Works. We've implemented an artificial wetland there. And another one, it's in uMngeni Wastewater Works. We also have an artificial wetland there. So yeah, I think if you can look at those as one of the scenarios.
So for those ones, so I guess there's a portion of is part of the outflow of the wastewater treatment works going through the artificial wetland before discharging, is that?
Yes.
Yes. That is the intention, especially for Davil, when some of the outflows are diverted to the wetland, and yeah, before you can discharge into the uMsunduzi River.
Okay, so that's quite an easy one to represent if there is some before and after data. Because the outflow from Darville and uMngeni will be, they're added into the model just as a time series of flow and concentrations. So if there's some information about how the flow and concentrations change before and after the wetland, we can put that into the model to see how it passes through the system. How it changes what's reaching different points further down on the river. So that's an easy one to do, because we're not actually, I'm hoping there is data being collected upstream and downstream, like before it goes into the artificial wetland and after it comes out. I wouldn't look to SWAT at this scale to model what's actually happening within that artificial wetland, because it's a relatively small system, and the model's not representing flow at that scale. Like I don't have a tiny little wetland HRU right next to those stations. And also they are piped flows from a wastewater treatment works. But if there is upstream and downstream data of what the flow looks like going in and what the flow looks like going out, or estimations of how much it should change, then that's quite easy to put into the model to see like how it could change the river further downstream based on adding those at the effluent point. Is anybody on the call? Are you working with those directly? Anybody who's here on the call?
Yes, we were just discussing some of the data that we have for those wetlands. So we do have a team who is currently monitoring those wetlands, and they are collecting water quality data. And they are also collecting various citizen science data. So in terms of water quality, it is lab data that we analyze at the lab. I'm not sure about flows. I was hoping that that's one from my team who is actually working with those teams on the ground can comment. But yeah, we'll just look for. We will engage with them and see what kind of data we are currently collecting. But I can confirm that there is a lot of monitoring going on, and we do collect the data.
Okay, great. That's great, because then that's a simple one to add. In terms of degraded wetlands elsewhere, that is one we can do. And I hadn't, so this is great because I hadn't thought through, but I'm thinking now about some of options in the model for adding that. There is actually one can add tile drains. One can add drains into an area. I'll find it. Yeah, you can add drains into particular areas. And if that's actually a change we want to model, I should actually look at where the tile drains are in now, or where a lot of them are drained now, and then add those in so that make sure the baseline model actually has the tile drains and or has the drains in. I'll look at if tile drain, there's other drain options, I think. But then you can see what happens when they're taken out. In terms of wetlands being well mapped in our inputs, so that would also be, it would be adding, adding drains to what's mapped as wetland and maybe particular wetlands. And where they are, and are those the ones you're thinking of that are being drained? Just for example, I'm just looking at where are places that are being mapped as wetland. So there are quite a lot of there's a lot of areas being mapped as wetland that hopefully are some of the wetlands. So it would be a question of saying which ones are you thinking of? And interesting. Okay. And looking at how the model is incorporating them at the moment. Is this at a stage of is it at a stage of planning? Have there been identified wetlands that you're working on? Oops. Sorry. Slides are going by themselves. Some setting I haven't figured out here. Okay. If there are I'm not sure if anybody's speaking now, but everybody's muted. But if there is, I'm assuming that drains and stuff are mostly in the areas where the wetlands near agricultural zone or forestry. No, I'm not sure. You're muted if you are.
Yes, we are having a mini discussion here
Oh,
about
okay.
yeah, so yeah, I think we are also discussing trying to remember some of the studies that we were involved in wetland rehabilitation. Some of the work was being done by Sanbi. So we're trying to find out where the data might lie, but most of the upper catchments, especially upstream of Midma, your upper falls, there are a number of wetlands that have been converted for agricultural purposes. So is there isn't quite a number of them that we can build scenarios based on.
Could be, and it could also be a land cover change. If the wetland is now agriculture, and then the idea is that it would go back to being wetland, not the whole some edges of what's now mapped as agriculture, not the whole agricultural zone, for example, but the edges turn into, we could convert them into wetland. So it could be represented as a land cover change scenario. Either it's being mapped as a wetland now, but it has drains in it, which we can represent in the model, or it's actually not being mapped as a wetland now. It's mapped as agriculture or forestry, or and then one would rehabilitate it into wetland, pulling back the agriculture to some distance away from the water body. Then we'd put that in the model in a different way in terms of like actually changing the land cover on these zones. So then that would be mapping, what areas would change into wetland from forestry, etc. In terms of the urbanization question, has anybody seen any local area projections? Or do you work with that kind of data? Like, I guess it could also come from municipal planning documents. Because I'm guessing there is some interaction in terms of planning wastewater works for additional development, and what the projections are for the future.
Yes, Julia, I think Wisile can maybe comment on that. We are having a discussion here, but I think she can
Okay.
comment.
So yeah, sorry. Okay, sorry for that. Hi, Julia. So we're just discussing that to say our planning services team might have some information related to that, because they do provide estimates in terms of what's for example, the estimated growth rate in a particular catchment or a particular area. So I'd assume they probably get those projections from a data that's like associated to what you're asking for. However, I think the most detailed data that would probably be of use would be from the municipality, like you were mentioning, probably from their IDPs, the planning documents in terms of what's planned for development probably in the next 3 to 5 years, sort of thing. But I think we can probably just check with our planning services what they may have, and then maybe the rest of the data would probably lie with the municipalities.
Okay, great. So this would be a next step. Like doing these scenarios would be a next step, but it's good to like having an idea of what some of them might be will influence a little bit about like some final touches putting on the baseline model to make sure that we can, represent some of the changes that you're interested in. So this is very helpful to have this talk. Because there's there's the overall calibration, getting the model into the ballpark of representing the system, but then there's other details that you'd focus more on, knowing that this is the intention is eventually to use it to model some of these kinds of scenarios. So it really helps with some of the final touches to have an idea of this. So to do an urbanization scenario, as I mentioned, if it's an idea of like rezoning existing areas, then it's a matter of changing the densities. But if it's like actual spread out into urbanizing areas that are currently either indigenous vegetation or agriculture, it might be a case of making a whole new land cover map that includes these new urban areas with all the trends, like changing the indigenous vegetation into urban, or agriculture or what have you into urban or residential, I should say, and then re-importing that. But all the parameters associated with each land cover would stay the same, but the new map needs to get put in, and the HRUs need to get redrawn. So it would be about getting, how do we make that new map of what areas are changing, and what that looks like. But once you have that new map, then the process is straightforward. It just does take some labor. Right. So is there anything else? I'm just aware that we're almost at 4. Are there other things that are coming to mind in terms of scenario types or ideas that you're having? We can have some more back and forth by email and stuff on the specifics of these if you're setting some of them up. If there's no final ideas or points beyond this, we can obviously come back to it, but I wanted to capture what we could while we were together. This is the last big group session we had planned in terms of a course of like how the model works and how to implement different things in the model. Because there's been some software bugs I mentioned in terms of the reservoirs last time, the calibration's been a bit delayed, but we're making progress. I will do a final handover to Ntando and Futi and go through that with a smaller group. I think not everybody needs to be on a long technical fiddly call that might be, and that'll be like transferring the files and making sure you can open it and run it on your side. So that would be a next step, but I've covered all the theory behind where everything is and what, like how the model works across these various courses. So in terms of next steps, I'm doing those final calibration adjustments and fixing those the bugs and how the reservoirs worked that was causing me to get gray hair. But we're there is an updated version that will be resolved in, and then I'll be handing over files and check that it can run on your side. But this is the last big group that's been planned, big group session that was planned for the training in the background and how the tool works. So I hope it's been helpful, and I am happy to do some follow-up questions once you play with the full model version a bit. But the idea was that everybody has a concept of how it works so that you have an idea of what kind of data can go into it, and what kind of data can come out of it, and can go from there. Are there any final questions? This won't be our last interaction, but it'll be our last interaction as a big group that's scheduled for now. So if anybody has any last things they want to bring up in the last minute or two. Sorry, I cut it quite close to the end there. I will have some more back and forth.
No, Julia, thank you very much for these sessions. So I think on behalf of the team, I would like to thank you for your time and yeah, it's been quite an extensive course, looking at the fact that most of us, even though we do have background in hydrological modeling, but I think SWAT is a very, very intensive model and data intensive model as well. So thank you for your time. And I think yeah, I'm happy that you will also I think you mentioned that you can also avail yourself to when we have questions after these sessions.
Yes, yeah.
Yes, I think that will be very useful to us because I know that when we are running this model, we'll encounter a lot of issues. So if we can maybe get your, I know it's too much, but if you can still get your inputs there and there, even via email or something, but if you can get your inputs, we'll really appreciate that. Thanks.
Yeah, no, for sure. And yeah, the original intention was to have you running it already by now, but there was something in SWAT Plus that wasn't working the way that it used to work in the other version, but I've almost got it now. And then we will have more back and forth once you have it on your side. And yeah, thank you, and thanks for staying the course. I hope, and you have the videos. And I did say I will edit some of them down. I've just been sharing them before I've had time to edit them, but that's also part of what I'll be doing. Just to take out some of the breaks and coughing and other irrelevant stuff, so that if you need to go back to them, they're a bit more user friendly. So that'll come as well. But yeah, thank you, and I hope this helps going forward. These things, because they have so many moving parts, and there's a lot of things that go into them. They're always like they end up being iterative. So you do a first step that hopefully meets some needs, and then you work out how to improve it more over time. Yeah, so I look forward to engaging further, and thank you for being here, and I hope you have a good rest of the Thursday.
You too, Julia. Thank you very much.
Thanks, everyone.